When THOR 7 is launched, I will be at the Jupiter control room in French Guiana. So I will be right at the consoles where the launch is controlled. I will be in a small THOR team, which is declaring readiness for launch, basically. Working on such a program over so many years is taking a lot of dedication and patience. So to stay focused for that long period, no mistakes, nothing left between the cracks. We have to take this gigantic undertaking and breaking it into smaller subtasks so that everybody has their area to focus on and milestones within that area. So, for instance, we have the ground control. That's a huge undertaking that we do in-house in THOR, because that's basically in our control center to prepare everything. And then we have a dedicated team of engineers in the factory where the manufacturing takes place. And these guys, they have hundreds of documents and milestones to pass. So they are basically exposed to infinitely many small tasks that they have to look at diligently and complete and proceed with the next one. Leading such an undertaking is first and foremost basically an honor, because there are so many skilled and dedicated people. So I'm really proud to see all those staff doing a great job. They are experts in their field, and they sort of are independent, and they do take a huge responsibility within their area. So that's sort of the primary feeling. But then, of course, there's some things left, and I think allocating clear responsibilities and giving people authority and mandate to act is the key, so they are empowered to do what they need to do. I will go over to the launch site some 3 or 4 days before the actual liftoff. At that point in time, there is a so-called dress rehearsal, which is basically a dry run of the launch. So at that point, there's a clear countdown sequence that has been defined, and that's a day of sort of rehearsing the whole thing. So THOR, of course, has a team present during the entire 1-month launch campaign, but I will come in at the end, and I will support everything from that dress rehearsal until the actual countdown. What happens during the dress rehearsal is that we simulate the actual launch. So we take the entire day, which the launch also takes, and we just walk through all the steps and ensure that communication is working and that everybody is aware of their role and responsibility, and that it's basically ready for launch. The most crucial point of the launch is when the so-called solid strap-on boosters are ignited. So that's when that happens, there's no turning back. Those boosters will burn until they are depleted, and they have a huge thrust. So basically, when those are fired, the rocket is leaving the pad definitely. So up to that point, the launch sequence can be stopped. But then, after those boosters are ignited, that's it, then we are flying. Well, after the successful launch, I will hurry back to Oslo, because the launch, well, that's exciting and very important, of course, but there's a long way still for the satellite to go. So there's one leg on the journey, which is to reach the geostationary orbit, which the satellite is accomplishing on its own. Then it's subject to a lot of testing, and ultimately there's a procedure for THOR to take operational responsibility and ownership of the satellite at the end. I will know if the THOR 7 launch is a success after approximately half an hour, because at that stage the upper stage of the rocket will have brought the satellite up to a speed of almost or approximately 10 kilometers per second, and it will be located somewhere above Africa, 250 kilometers above ground. So at that stage, the satellite will be separated from the upper stage, and we will sort of know if the launch itself was successful. But then There's a procedure still to bring the satellite into geostationary orbit to test it and to transfer the operation, and that will be some 6 weeks later, which we will know if it's overall a success. The meaning of THOR 7 for our customers is that primarily Maritime Datacom's customers will get a fantastic asset that will enable them to basically sail anywhere between south of Svalbard in the high north, all the way to the European mainland, through into the Med and even into the Red Sea. So you can sort of imagine you have an offering where you can stay connected via broadband, you can surf the internet, stay on Skype, etc. So that's something that the maritime customers can look forward to. And this is made possible thanks to migrating to Ka band and high throughput technology. So we can basically shrink the antenna, make it more compact, while at the same time actually increasing the throughput. So for the broadcasting customers, THOR 7 means basically increased capacity. So this capacity, primarily directed towards Central and Eastern Europe, means that customers there can increase their offering number of channels, or they can migrate to higher definition content as well. And finally, there is also a customer segment that can benefit from a special part of the payload that is basically relaying huge quantities of data from Antarctica, from the troll station back to the Norwegian mainland. The amount of emissions coming out of a THOR 7 launch is actually a surprising piece of information, because if you have to look at the launcher and realize that it's a so-called cryogenic engine, so it's fueled by liquid frozen hydrogen and liquid frozen oxygen. And these two substances are brought together and they burn in the rocket engine, and the exhaust product is basically water vapor. So that's environmentally friendly. But admittedly, okay, we have also these strap-on boosters that are based on solid propellants. And from them there is a certain amount of CO2 emissions, and you can do the math and you'll see that it's comparable to a transatlantic flight, basically. So in the big scheme of things, the footprint is really quite minor. The THOR 7 satellite is different from my previous experiences in that it's using a Ka band. So that's a technicality, you might say, but it's basically starting to use a higher frequency band. So that's something new, and even more importantly is the concept of high throughput satellite, where you basically reduce the beam size, the footprint on the Earth, and you bring in numerous smaller beams, and that allows you to increase significantly the throughput of the satellite. So for us, we are sort of tenfolding the capacity compared to our previous satellites.